Right, this is Ms. Plant's video for GCSE Science. I'm going to talk you through proportionality for GCSE Physics. So proportionality is all about the relationship between variables. You need to know that this symbol here means proportional to. And you also need to know that constant means the same value. You probably don't know that. Right, so two types of relationships that you need to be able to identify: when things are directly proportional to each other and when things are inversely proportional to each other. So directly proportional. Now you get two values, you plot a graph, your graph comes out like this, a straight line going through the origin. That means your values are directly proportional to each other. It means that as x doubles, y doubles. Y is kx, is how we mathematically write that, or y is proportional to x. K is the constant of proportionality. Now, you don't have to plot a graph. You can prove this from data. So if I've got a data set like this, which they might give you in the exam, I can prove it by doing the y value divided by the x value. I could also do the x value divided by the y value. Doesn't matter too much. And that always gives us a constant value, and that's proof that they're directly proportional. So in this case, 1 divided by 2 is a half, 2 divided by 4 is a half, 3 divided by 6 a half. So I could do all those three values, do at least 3, and prove that there's a constant. The constant is k. That's proof that they're directly proportional. Now, an example of this would be the Newton's second law. Force is mass times acceleration. This shows us that force is proportional to acceleration. If I change the force, the acceleration will change. If I plot a graph of that, I get a straight line through the origin. Again, it doesn't matter about the gradient of the line, so long as it's a straight line through the origin, meaning that force divided by acceleration is always a constant. And in this case, the constant is mass. You can kind of like talk about the gradient a little bit, because the gradient of these graphs is the y value divided by the x value if it's a straight line through the origin. So the gradient of this is a over f. So the gradient is 1 over m. That's kind of like, I guess, a bit further down the line maybe. Now, the other type of proportionality is inversely proportional. Inversely proportional, the graph looks like this, and it means that as x doubles, y halves. Or, mathematically speaking, y is k, the constant of proportionality, divided by x this time, and that means y is proportional to 1 over x. This is inversely proportional. Again, you identify this, you get your data, you plot the graph of your data. This is what the graph looks like. Oh, they're inversely proportional. However, you can also prove it using data, and this time you prove it by saying the y value times the x value is always a constant. So the y value times the x value is always the same. That means they're inversely proportional. So I get my data, I take three values, I multiply the values together. If it's the same value, that means that they are inversely proportional. So in this case, they are 2 times 8, 16, 4 times 4, 16, 6 times 2.67, just about 16. So this data here is inversely proportional. I don't have to draw a graph. I can prove it like that. That's what they might ask you to do in the exam. And another example here, same equation as before. Newton's second law, force is mass times acceleration. This time A is F over m. A is proportional to 1 over m, meaning A times m is a constant, and it just so happens that that constant is force in this case. So this is you've got a constant force, you're changing the mass and you're measuring the acceleration in this example. And you plot a graph of it, and you should get a graph that looks like this. And you can say, oh, because of this graph, it's inversely proportional. But again, you could also do it from a set of data.